Hi, and welcome to MSc. In this video, we're going to be looking at solving quadratic equations using the method of completing the square. So the challenge with solving quadratic equations, and why often we then default to factorization or quadratic formula, is that there's no real easy way to isolate x when we have x in two terms and their different exponents, right? That really is what the challenge of it is. But we know that if it's in vertex form, I only see one x, and it only has one exponent. There's not two different x's with different exponents. Now we do understand that if we FOIL out the bracket part, that we'll get standard form back again. But I can rearrange this in such a way that I can solve for x. And of course the link between these two forms is the method of completing the square. And so what we're going to be able to do is we're going to be able to solve quadratic equations by using the method of completing the square without having to use the quadratic formula or factorization. So let's take a look at an example of this. So here we have a quadratic equation. This part here is in standard form. I have two x's, so my options right now are quadratic formula or factorization. This is not easily factorable, so we can't do that. We'd have to use the quadratic formula. Let's take a look at how we would solve this by using the method of completing the square. So what we do is we kind of almost ignore the zero for a moment, and we just treat this like it was a quadratic function, and we're trying to put it in vertex form. And so the method of completing the square, I'm going to go over quickly here, but I do have another video on that method, so if you want to refresh that method first in your brain, go check that one out and then come back. First step is to factor the number in front of the x squared. Common factor it. So we're left with this, and it's going to be 4/3 x minus 5. Then we have a little bit of the thought process. We have to take half of the number in front of the x. So half of 4/3 is 2/3. And then I want to take the 2/3 and I want to square it. So that'll be 4/9 if I square it. And so it's this 4/9 that I want to use in the next line of my equation. And so it's 0 equals 3, and it's x squared plus 4/3 x, and then we're going to add 4/9, and we're going to subtract 4/9, and then we close bracket, and we still have the 5 on the end. Then we're going to collapse this part here down to make our perfect square part of the vertex form, and this part is going to be removed by multiplying by the coefficient out front, which in this case is 3. Again, in another video, I might break this up into multiple steps. I'm going to do this in one step for you. So we're going to leave the 3 out front. Inside the bracket, we have x, and it's going to be plus, because this is a plus sign here, plus, and it's going to be the half piece, the 2/3, the half of whatever's here. So 2/3, and that's our perfect square. And then we have the 4/9, the negative 4/9 multiplied by 3. So by multiplying by 3, the 9 and the 3 will reduce, and I will get negative 4/3. And this is minus 5. Now we have to add these guys here to get them to have common denominators. I'll show that work here for you quickly. Common denominator is 3, and this would be 15/3, the negative 5, and we'd have 0 equals 3x plus 2/3 squared, and this total here is negative 19/3. Okay, so now we basically put it in vertex form. You can see the vertex here. The vertex will be at negative 2/3, and the y value of that will be negative 19/3, but we're not interested in the vertex here. Likely we're asked to solve this quadratic, right, equation. This isn't a function right now. We're looking to find when this is true. We're looking for the zeros. So what we have to do then is rearrange now for x. So we're going to take this and move it across the equal sign. It's negative here. It'll become positive on the other side. 19/3 equals 3x plus 2/3 squared. That's a 3 on the denominator there. Then the opposite of multiplying by 3 is dividing by 3. So I'm going to divide both sides by 3, and that's going to result in a multiplication of the denominator. And this is then going to be, bracket, x plus 2/3 squared. Now what we can do is we can square root both sides. Square root, we're going to square root, and we realize when we square root that we actually get two possibilities. We get a positive possibility or a negative possibility. So let me clean this part up here. We have plus or minus the square root of 19 over 9. Well, square root of 19 is just a mess. We're going to leave that alone. But the denominator, square root of 9, is just 3. So that's nice. And this is going to equal x plus 2/3. So as a final step here, I'm going to take the plus 2/3 and move it across. And I'm going to say that x equals, and that's going to become negative 2/3 plus or minus square root of 19 over 3. So this tells me my two intercepts. It tells me that I have an x1, my first x value that solves this quadratic equation is negative 2/3 minus root 19 over 3. The other value of x that also makes this equation true is negative 2/3 plus root 19 over 3. Okay, if we want to relate this back to the function, then we can take a look at what that graph looks like. But this equation is now solved. We know the two solutions. These are the two x values that we can get. And we solved this not using the quadratic formula, although these things are related. I'll talk about that in a moment. But we found using the completing the square method these two x values that make my original equation appear true. If this equation was finding the zeros or roots of a quadratic function, then we could look at this function and try to interpret our roots here in a different way. So let's take a look at what this graph would look like. So if this, I've switched over to Desmos here, if this was a quadratic function, and it's the same function that I just, or the same equation that I just solved, we can see here that we have these values for the roots, and if you convert and round the values that we found, that's accurate. We can see the vertex, and we can see the negative 2/3, and this value here is the negative 19 over 3. And so we've solved that. That's what this has done for us, which is interesting. Hopping back over to our work here, we can see if this was the function f at x that was represented by 3x squared plus 4x minus 5, which is what we solved originally, then we can see then that we have our f of x axis and our x axis, and we can see now that we have an axis of symmetry. And what's interesting about this axis of symmetry is that it is going to be along the line x equals negative 2/3. That's this part right here out front. That's your axis of symmetry. Right? And not only that, but we also know that this distance and this distance, if I'd drawn things perfectly well, are equal, and that they equal the they equal the negative, the 19, like the distance of themselves is root 19 over 3. So we can see here that we have our negative 2/3, and if we subtract negative root 19 over 3, we get this value. And if we wanted to actually plot a coordinate here, this would be negative 2/3 minus root 19 over 3, comma 0. And this point right here, my x2 value would be negative 2/3 plus root 19 over 3, comma 0. And so we can interpret it if it came from a quadratic function. If it's an equation that we're just trying to solve, we can solve it without the use of the quadratic formula, but rather the method of completing the squares. As it turns out, that's how we get the quadratic formula. If you complete the square for something in standard form, ax squared plus bx plus c, and you don't have values for a, b, and c yet, but you complete the square, you'll get the quadratic formula. And that's pretty cool. And you can try that out on your own. Leave a comment if you'd like to let me know how successful you were with that exercise. I hope this example of using the method of completing the square to solve a quadratic equation has been helpful. As always, thank you so much for listening and watching.